So let's go ahead and see what this says. Creates a reference. A J frame is sort of like a window around it. So you're creating a frame is basically a window that you're creating. It's going to put a title on it. It'll set the size to 200 pixels by 150 pixels. That'll make it visible so that you can see it. And then down here, we're basically doing the same thing, really. So here we have it here. We can run this. And eventually it should create. Okay, there's window 1, window 2. There they are, window 1, window 2. So that created a window, a frame. Very basic GUI stuff. We'll get into some more, window stuff later on. Any questions on that one? Okay, instance variables belong to a specific instance of an object, and we already talked about this a little bit. We could use bicycle or circle, it doesn't matter. Radius is an instance variable, object. Call it an object variable too. Instance and object are generally used interchangeably. It belongs to the object. And how do you know it's an instance variable? Well, two ways. One is that it's declared, there's no static, right? Because static would mean it belongs to the class. It's a class, usually a class property or a class variable. You don't usually, well, you could have a class variable, I shouldn't say that. Okay, it's declared at the class level, and it's not static. That means it's an instance variable or an object variable. You can also have something called a method or methods or method variables. Now, methods are these guys down here. Get area is a method. It's an action. It's something it can do. It's a behavior. And what this does simply is get area. We look at bicycle. Bicycle has even more. Bicycle's got set, which allows you to change the name of the owner and the license number too. Set. Set means to change or to mutate. Get returns the value or accesses the value. Getters and setters are often called accessors and mutators. One of the things I can show you on this, for example, is let's say that I go ahead and I delete all these. Then I can right click in here and go to, I think it's insert code, and I want a getter and setter. Okay, so let's say getter and setter for both. Now, Java goes ahead and creates all those for me. Getter and setter. These are the accessors and the mutators. It knows how to do it itself. So those are all methods. Methods can do things other than getting and setting. But those are pretty much the principles of it. Static variables, constants, and methods. Okay, so we've already looked at some of them. In circle, pi is a static constant. Actually, it's not. Right now, it's a static variable, which means I can change it. So in test circle, I can say circle.pi is equal to 5. And that works. So it's a variable that I can change. That makes it a variable. However, it should be a constant, which means really that it's read-only. It's a variable that's read-only. I can make it a constant very simply by going to circle and adding the word final. That's all. That's the only difference between a variable and a constant is the word final. Functionally, there's a difference as well, because now I get an error saying pi cannot assign you cannot assign a value to final variable pi. I can no longer assign a value to it because it's now read-only. Final makes it read-only. You can also have static methods that are not tied to a specific object either. So what would that be here? Maybe under bicycle, I want to create a static method. And we'll put it at the top. Generally, yeah, and I can say public static. Let's say I want to make this an int or a double maybe. Let's just make it a string. Version or get version. Version 2.5. It's static, which means it belongs to the class. And because what I'm saying is that the version of this class is version 2.5. And that's the same. It's not going to change. You could say the square footage of a house. That's the same. It's not going to change. It belongs to the blueprint. So in Lab 4, I can just say something as simple as bicycle dot get version. I can do that, no problem, because it's static. Means it belongs to the blueprint, to the class. I know that could be confusing. Does anyone have any questions so far? You think of static, you think of something that would be universal to that blueprint or to that class. For example, the square footage of every house built from that blueprint, that would be static because it doesn't change. It's always the same for every house. But the color of the carpets would be non-static because unless you're not giving people an option as to what color their carpets can be when they buy the house, it would definitely be dynamic or object. Can too many static variables cause a memory? No. Garbage collection will take care of it. Yeah, garbage collection will take care of it. A memory leak happens when memory is assigned and all the references to it, but no longer has any references to it. So the memory, you have no way of accessing the memory. This was a big problem with C++. So Java came along and created garbage collection, which essentially looks for memory leaks. And when it finds them, it gets rid of the memory. So if you allocate memory and you never deallocate it, you can get rid of it, delete it, then eventually that memory is used and will never be reusable by anything until you reboot the computer. So what would happen with memory leaks, and a lot of software had this problem, particularly programs written in older languages that had no way of dealing with memory leaks, unless the programmers were very good about writing their code to make sure they released all memory when they were done with it, which a lot weren't, you had memory leaks. And a memory leak is simply taking up memory and having no way to get rid of it, no way to reuse it until you reboot the computer. So the end result would be, if you have a program with memory leaks, eventually it's going to exhaust the computer's memory and it starts going into virtual memory or paging memory. When that happens, the computer starts slowing down a lot. Eventually the computer gets so slow it's unusable and you have to reboot it. I'm sure everyone has had that problem with, probably more Microsoft than Mac, but even the Mac, you can have that problem. And essentially, you've used your computer for days on end without rebooting it, and it starts getting really slow, and you get so annoyed you reboot it, and then everything's fine again. Well, that's probably because those programs, even modern programs, still have memory leaks. Shouldn't. We've been known about memory leaks for, gosh, 20, 30 years at least. So I don't know why modern software would have memory leaks. It shouldn't. But it does. But that's one of the big improvements with Java was the built-in garbage collection that looks for memory leaks and gets rid of it. So we've got this again with circle, and again here's some more examples of UML. That when you instantiate the circles with a default constructor, you get the default value. So this is saying a static variable would be the number of objects. So we could do that too. We could do that with circle, no problem. Say static int. We probably want to make it private. I'll just call this object count equals 0. And then every time we instantiate an object, I'll say plus plus object count, which really just means object count with an object count plus 1. That's all it really means. And we can do some stuff to show you what happens. And let's do a backslash in. Let's say count is %d. Percent. My percent's in there. And then we'd have to do the same thing in all the constructors. So this thing is essentially keeping track of how many objects we have in play. So if we go and run this, we'll see that the first time the count is 1, the second time it's 2. So circle is self-knowing that it's got 2 of it have been created. And you can do that. Self-knowing. And that's why it's static. Because it's the same no matter what. Static is static. Single copy. One single copy belongs to the class. Belongs to the blueprint, not to a particular house. That's what they're doing there. And we already saw circle with static members. Pretty sure that's what I just showed you. This also talks about public and private. I talked a little bit about this already. We can go back and maybe the bicycle example is a better one, but essentially the rule here is that all your data should be private. If we go here, I know that I can say c1.radius is equal to 2. I also know that's a bad idea. So I can come in here and say, I don't want the whole world to be able to change the radius because that's, who knows what's going to happen. So I can say this is private. Now if I go over to simple circle, I get an error message. It says it's private. You can't change it. It's done. But maybe we want to be able to change it. We just want to be able to change it in a controlled fashion. So I can say insert. I can do setters and getters, I guess. Let's do both for radius. See, here it is. So one of the things I might want to say, the problem with letting them do it themselves is they may go and say c1.radius is equal to -1. Well, is that valid for radius? No, it's not. But if we leave it as public and open, they can do that. So we might say, well, we'll let you do it, but we want to validate what you're giving us first. So we can say here in the setter, if radius is greater than 0, then we're going to go ahead and let you do it. Otherwise, we're not. So now here I can say c1.set radius 2.0, run this, and it'll work. Somewhere along the line it worked, right? Because it gave us a custom construct area is 12.56, and that's because we made it 2. However, if I try to say -2, now it won't work. Or it'll work, but it will use the default value of 1. Because in here, I said, I'm only going to let you set the radius if it's greater than 0. Because nothing else makes sense. It's not a valid value. And you might want to set some range on it. It's got to be greater than 0 and less than 100. Or something like that. So this is what we call encapsulation. Private data, public access. Public controlled access is what I should say. Public controlled access. This way, it's like a bouncer checking your ID at the door, making sure you're older than 21. If I make it public, it's like opening the bar door and letting anyone come in. How long will you keep your liquor license if you do that? Not very long. So you put a bouncer on the door checking IDs. That's the whole point behind it. Private data, public controlled access. That is encapsulation. One of the primary reasons why we use object-oriented programming. Well, that and there's no other option today. Everything's object-oriented. Any questions?